Welcome everyone. I'm thrilled to be here with you today to talk about something that's absolutely foundational to EMS education. That's item writing and analysis. Whether you're a seasoned educator or just starting out, this session is designed to give you practical, actionable tools to improve your assessments. In part 1, we talked about item writing and how to foundationally build those steps. Now in part 2, we're going to discuss the analytical side of things. So let's start with a simple but powerful question. Why does exam analysis even matter? Think about the time and effort we invest into teaching. If our exams don't accurately reflect what students have learned, or worse, what if they're flawed? We risk undermining all of that hard work. Item analysis isn't just about statistics, it's about fairness, accuracy, and accountability. It helps us identify which questions are working and which ones aren't and why. And with our accrediting bodies now requiring regular validation of high-stakes exams, this isn't optional anymore, it's essential. So today, we'll break down the process step by step. You'll learn how to calculate the difficulty and discrimination values, evaluate distractors, and use data to improve exams. Don't worry, if you've never done this before, I'll make sure you leave here confident and ready to apply these techniques. For those of you who don't know me, my name is Samantha Grimsley, and I am the program director over at Weatherford College here in Weatherford, Texas. My contact information is down below, and if you have any questions after this presentation, don't hesitate to send me an email or give me a call. Let's take a look at what we'll accomplish today. By the end of the session, you'll be able to explain why item analysis is critical for maintaining exam validity and fairness. You'll be able to calculate key metrics like the p-value and d-value using real test data, interpret those results to identify flawed questions and improve assessments, apply these techniques as part of your program's continuous quality improvement processes, which are now becoming a requirement. These objectives are not just theoretical, they're practical skills you'll use to strengthen your exams and support your students. Item analysis is the process of reviewing how each test question performed after the exam is administered. It's like a diagnostic tool for your test. We ask questions like, did the students understand the material? Was the question too easy or too hard? Did it measure what it was supposed to? By analyzing performance data, we can identify which questions are effective and which ones need revisions. This isn't about punishing students, it's about protecting them from poorly written items and ensuring our assessments are fair and meaningful. Reliability and validity are at the core of a good assessment design. So let's talk about reliability. This means your test gives consistent results. If a student takes two different versions of the same exam and scores very differently, that's a problem. A reliable test ensures that performance reflects knowledge, not luck or test design flaws. Now with validity, it's about making sure your test measures what it's supposed to. For example, if you're testing airway management and the question should assess airway knowledge, not reading comprehension or test-taking tricks. Item analysis helps with both. It improves reliability by identifying inconsistent and misleading questions. It also improves validity by ensuring each item aligns with your learning objectives and course content. Together, these principles help ensure your exams are fair, accurate, and defensible. Now, we're going to get into the heart of item analysis. And there's two key metrics. We call them the p-value and the d-value. The p-value tells us how many students got a question right. It's pretty much measuring the difficulty of the question. The d-value, or what we call the discrimination index, tells us whether the question is doing a good job of separating high-performing students from low-performing students. When you look at these two values together, you get a much clearer picture of how well a question is working. A good question is one that's not too easy or too hard, and that high performers tend to get right more often than the lower performers. All right, let's break down the p-value. It's a number between 0 and 1 that tells you how many students got a question right. A high p-value like 0.90 means the question was easy, such as 90% of the students got it right. A low p-value like 0.20 means it was hard, only 20% got it right. It's called a difficulty index, but it works in reverse. The lower the number, the harder the question. Why does it matter? Because a good exam has a mix of easy, moderate, and hard questions. If every question is too easy, you'll not really be testing knowledge. They're all too hard, students get discouraged and they don't get useful data. Let's look at this table as a quick reference for interpreting these p-values. If we have a 0.0 to 0.3, we're indicating this to be extremely difficult. It may be too hard, or there may be even a miskey there. 0.3 to 0.5 being very difficult, could be challenging but potentially useful for students. 0.5 to 0.7 being moderately difficult, which is honestly ideal for most exams. 0.7 to 0.9 being moderately easy. It's still useful, especially with that foundational content when we were talking about Bloom's taxonomy. And 0.9 to 1.0 is very easy. It might not be very helpful in distinguishing student performance. The goal isn't to eliminate easy or hard questions, but to balance them. A well-designed test would challenge students without even overwhelming them. Calculating the p-value is really simple. Count how many students got the question right. Divide that by the total number of students who answered it. So let's use this example. If 60 out of 100 students got it right, the p-value is 0.60. That's moderately difficult compared to the table of what we were looking at in the last slide. This number gives you a quick snapshot of how challenging the question was for your group of students. And when you do this for every question, patterns start to emerge. Maybe certain topics are consistently too hard, or maybe some questions are too easy to be useful. Now on the other end of the spectrum, let's talk about the discrimination index, or the D-value. This metric tells us how well a question separates high-performing students from low-performing ones. Here's the idea behind it. A strong test question should be answered correctly by students who understand the material, and missed by those who don't. If both groups perform the same on a question, it's not helping us distinguish who truly knows the content. The D-value ranges from negative 1.0 to positive 1. A positive value means that the question is working well and it's being answered correctly by stronger students. A negative value is a red flag. It suggests weaker students are outperforming stronger ones on that item, which could mean the question is confusing, miskeyed, or even misleading. Now looking at this table as an interpretive tool, if we have an item that is equal to or greater than 0.4, we indicate this to be a very good item. If it's a 0.30 to 0.39, it's a good item but needs some improvement. 0.20 to 0.29 means the item needs to be improved, and anything less than or greater than 0.19 means the item needs to be removed and reworked completely. Now remember, the D-value, or what we call the discrimination index, is how we evaluate how well a test question distinguishes between high and low performers. We start by splitting students into two groups. The top 27% based on the overall test scores are what we consider our higher performers. The bottom 27% are considered our lower performers. Why 27%, you might ask? It's a statistically effective cutoff that gives us a strong contrast while leaving out the middle group, which tends to be less informative. So here's how we calculate the D-value. Count how many students in each group got the question right. Convert those counts into proportions by dividing the number of students in each group. Then we'll subtract the bottom group's proportion from the top groups. So here's a really good example. If you have 25 out of 30 students that got it right, then we have a 0.83 per. If you have 10 out of 30 of the bottom students that got it right, then that's 0.33. If you take 0.83 and subtract it from 0.33, it equals 0.50. That means that the D-value is 0.50. This question is doing a great job of distinguishing between students who understand the material and those who don't. Now, let's shift on over to distractor analysis. This is looking at how the wrong answer choices performed. In a multiple choice question, the incorrect options are called distractors. Good distractors should be plausible enough to attract students who don't fully understand the material. Here's what to look for in a distractor. If no one picks it, it might be too obviously wrong. If high-performing students pick a distractor, the question might be misleading or confusing. If low-performing students are consistently drawn to a distractor, that's a sign it's working well. It's tempting, but incorrect. This analysis helps you to refine your questions. You want every option to serve a purpose, not just fill a space. So there's good news for those who use LMS systems. All three large performing platforms such as Canvas, Blackboard, and Moodle offer some solid built-in tools to help deep dive into the analysis. So even if you're comfortable with equations and mathematics skills, you do have some helpful tools at your fingertips. And this example is of Moodle. In both the previous slides, I've highlighted in red the sections that you should be looking at for that discrimination and difficulty factor. Because my school uses Canvas, this was the best way for me to showcase reporting. After I've built an exam and I've conducted it with my students, I go in under Report section and I run and generate a report. The report is going to look at how each question performed, how many students selected each distractor, and basic statistics like the p-values and d-values are going to be calculated. This means that you don't have to manually crunch those numbers for every exam. Canvas gives you that head start by showing you which questions might need attention. It's a great way to begin integrating item analysis into your workflow without needing that extra software and spreadsheets. This slide shows a visual representation of how item analysis data might look in Canvas or similar platforms. You'll see breakdown of student responses, which distractors were chosen, and performance trends. Even if you're not using Canvas, this kind of data can be gathered manually. The key is to start looking at your questions, not just as content, but as data points that tell a story about student understanding. Now let's go look at a couple of examples of how that looks in Canvas versus the test question and the analysis. So based off this question of which of the following abdominal structures is responsible for the reabsorption of fluids used in the digestive system? Based off of our part 1 presentation, we would call this a recall of facts or foundational knowledge. Based off the item analysis though, the question has a difficulty index of 0.95. That means that 95% of the students got it right, or in this case, there's 20 students in this class, so 19 of the 20 in this case. So it's a very easy question. Now that's not necessarily bad. Some of the easy questions are appropriate, especially if they cover critical must-know content. But if too many questions are this easy, this exam might not be challenging enough to truly assess student understanding. Now here's where it gets interesting. The discrimination index is 0.14. That's a negative number and that's a red flag. What does that mean? It means that a lower performing students were more likely to get this question right than a higher performing student. That's the opposite of what we want. Ideally, strong students should be getting these questions right more often than the struggling students. So what could have caused this? The question might be a miskey. Maybe the correct answer was marked wrong. It could be that it was too obvious, so even students guessing it got it right. Or it might be confusing to stronger students who overthought it. This is a great example of why we don't just look at how many students got a question right. We look at who got it right. That's what makes item analysis so powerful. It helps us at spotting questions that aren't doing their job, even if they seem fine on the surface. Now looking at the scenario-based question, the students were pretty much divided between a bowel obstruction or diverticulitis on this patient. This question performed quite well though. The item had a difficulty index of 0.68, which means 68% of the students got it right. Out of the 20 students though, that's about 13 or 14 correct responses. This places the question in the moderately difficult range, which is ideal for most exams. It's challenging enough to test understanding, but not so hard that it frustrates students. Now, the discrimination index is 0.60, and that's excellent. It tells us that high-performing students were much more likely to get this question right than the lower-performing students. That's exactly what we want. It means the question is doing a great job in distinguishing between those who truly understand the material and those who may not. This kind of item strengthens your exam's reliability and validity. It's not just measuring recall, it's helping you identify who's ready to move forward and who might need some remediation. So when you see a combination like this of a moderately difficult and a strong discrimination, you know that you've got a solid test question. These are the kinds of items you want to keep and model future questions after. In this scenario-based question, students were given information to where they would have to differentially diagnose what they believe is going on with the patient and then treat them accordingly. This question had a difficulty index of 0.58, which means 58% of the students answered it correctly. So just under 12 of the 20. That puts that at a moderately difficult range, which is generally a good place to be. It's challenging enough to assess understanding, but not so hard that it discourages students. Now let's look at the discrimination index, which is 0.27. That's a positive value, which means it's what we want. It means that higher performing students were more likely to get this question right than lower performing ones. However, it's not just below the commonality of accepted threshold of 0.30 for a strong discriminator. So what does this tell us? It tells us that the question is functionally acceptable, but there may be room for improvement. It might benefit from a small revision, maybe rewording the stem for clarity or adjusting the distractors to make it more plausible. It's not a bad question, but it's not a standout either. This is a great example of a question that's worthy keeping, but also worthy of watching. It performs similarly on future exams. It might be time for a candidate refinement. Now, I can tell you for this question, I actually went in and rewrote the answer choices as I didn't find them to be very sourceable. Let's take a closer look at this question from our exam. It's another scenario-based question that gives a lot of information and asks the student to diagnose the condition. This is a great example of a well-performing item based on the data. The difficulty index, or what we call that p-value, is 0.53, which means just over half of the students answered it correctly. That puts it in the moderately difficult range. It's challenging, but not overly so. The discrimination index, or the d-value, is 0.63, which is excellent. This tells us that the question did a great job of distinguishing between high-performing and low-performing students. In other words, those who understood the material were much more likely to get it right. This is exactly the kind of item we want to see on our exams. It's not too easy, and it's not too hard. It clearly separates students who have mastered the content from those who haven't. In that, I also was able to source the information back to the condition and proving that the answer is the correct answer. While I understand that such LMS programs can build a spreadsheet out for you explaining all of this data, I myself like to utilize this form that I was given when I started out as a program coordinator. So in this slide, it shows a real item analysis spreadsheet from that class of 20 that we've been talking about. Each row represents a test question, and we're using the data to decide which items to keep, revise, or toss. So let's break down what you're seeing here. The difficulty column, which is that p-value, is the portion of students who got the question right. So for example, a value of 0.95 means that 19 out of the 20 students answered correctly, and we know that that's very easy. Now on the column to the right of it, that discrimination index column, this is how well the question separates the higher performers from the lower performers. A strong d-value, again being anything above 0.30, means the question is doing its job. A negative value like 0.14 means that something's wrong. It might be confused or it needs to be rechecked. So let's look at how this data was used. As you see in number 29, this is a really great example that might need to be revised or removed based off its performance metrics. The difficulty index is 0.16, which means that only 16% of the students got it right. That's an extremely difficult, possibly too difficult to be useful question. It could indicate that the question wasn't clearly written or wasn't covered in class, or it's just simply too advanced for the level of the exam. The discrimination index is 0.19, which is below the ideal threshold. While it's still positive, it's still not enough to confidently say the question is distinguishing between high and low performing students. This combination of a very low p-value and a weak d-value suggests the item might be flawed. It's not helping us measure student understanding effectively, and it could be unfairly penalizing students. Before discarding, we should ask ourselves, was the material taught clearly? Is the question sourceable and aligned with the curriculum? Are the distractors plausible? Could there be a miskey or a typo? If the answer to any of these is yes, then we need to be revising it. If not, we need to retire the item and replace it with something more effective. In this sense, I found that there was 2 plausible answers. So I put in there that we needed to fix it and toss it and gave a point back to the students. As you can see in number 15, we have that 0.58 versus a 0.36. I put the question in there for the validity of knowing what that number of tests goes to. However, if you notice, it says volume 2, page 1315. It means that I was able to source the information correctly. So in that sense, this test item is going to stand. Yellow highlights in the action column mean I'm not confident with the reliability of this item and I'm going to be tossing and rewriting them. At the bottom of the sheet, you'll see that I have multiple categories. That's for each of these exams. This is a common question I get asked all the time. How often should I be analyzing my exams? And the answer is every test, especially your high stakes ones. Now with our accreditation teams requiring documentation of validation, our site visitors will ask to see how you're analyzing your exams. It's not just about compliance, it's about quality. Regular analysis helps you to catch issues that are early on and improve your question bank and ensure your assessments stay fair and defensible. So in that last slide, when you looked at the bottom, all of those different files end up being different tests that I'm doing analysis on. They're all my module exams, midterms, and final exams. Because the students deserve fairness. If a test question isn't fair, they get a point back, which benefits their grade. Why should I penalize them for unfair test questions? Once you've done your analysis, here's what to do next. You've got to start reviewing those low-performing questions. So, are the answers plausible? Was the material taught clearly? Check for any kind of miskeys or typos. Even small errors can throw off results. Look at the answer choices. Are there any 50-50s? Do 2 options seem like they're equally credit? Ask yourself, is the question sourceable? Can you trace it back to a clear learning objective or reference? Can you find that the answer is the correct answer? If you're looking at previous data, can you track repeat offenders? Such in my case, I look at the 2 years previous to the class that I'm in to see, has this test question performed badly for the last 2 years? If it has, it's probably time for a revision or to retire it. This step is where your experience as an educator comes in. Use the data to guide your judgment, but don't be afraid to make changes. It's why it's very important that you write your own items and that not somebody else is writing them for you. I mentioned this in part 1, but it's worth mentioning again in this section. Even the best written exams can become compromised if it's not secure. So let's talk about protecting those test contents. First, if something seems off, Google your question. But again, Googling questions from time to time, it's not a bad idea. You might be surprised how many test items end up online, sometimes even with answer keys. If you find your question out there, it's time to retire or revise it. Second, proctor your exams in person whenever possible. Online testing is convenient, but it opens the door to cheating. If not carefully monitored, and even the best monitoring systems still don't find all of it. Third, rotate and refresh your question pool regularly. Don't use the same test every semester. Even small changes like rewording distractors or changing the order can help maintain integrity. Remember, test security isn't just about preventing cheating, it's about protecting the value of your program and the credibility of your graduates, and above all, patient advocacy. The goal in all of this is to reinforce the fact that good assessments are built, not guessed. So take a moment to reflect on this. Are your exams doing what you want them to do? Are they fair, accurate, and defensible? If not, you now have the tools to start improving them. Remember, item analysis isn't just technical requirement. It's the way we support our students and strengthen our programs. If you want access to the Excel form that I utilize, Go ahead and scan this QR code. Help yourself to the form, download it to your computer, and let it rewrite your world. As we wrap up, I want to leave you with this thought. Every question on your exam is a reflection of your teaching. When we take the time to analyze and refine our assessments, we're not just improving tests, we're improving outcomes. So what's your next step? Start small. Choose one recent exam and run a basic item analysis. Look at the p-values, the d-values, and the distractor performances. You'll be surprised with how much insight you've gained. And if you're using tools like Canvas, you already have access to some of this data. Use it. Make it part of your routine. Because when your assessments improve, your students succeed. And that's what we're all here for. If you have any questions, don't hesitate to call me or send me an email. I hope you enjoyed this part of the presentation, and now you're set up to write items and then again, do an analysis on them. Thanks for tuning in, everyone.